All right, so in the last video, we cooked up a derivative for the inverse sine function. We needed to get into the original, we worked back from the inverse function to the original trig function, the standard trig function. We took a derivative implicitly. We ended up using a triangle, but the long story short is we were able to find a derivative for the inverse sine, which is kind of cool. And it sort of begs the question, is there a derivative for inverse cosine? And it would seem natural that there would be. So let's go through this as well to figure out what the derivative of the inverse cosine is. And we'll employ the same tactic that we did last time, which is to say if y equals cosine inverse, what makes finding this derivative difficult is the fact that we've got the inverse cosine function. Let's try to get this in form of the original cosine function. And well, x here, let's remind ourselves, is playing the role of our ratio, and y here is playing the role of our angle. So let's just rewrite this as cosine y equals x. And now this is an implicit equation, but we know how to take the derivative of implicit equations. What's the derivative of cosine y? That's going to be negative sine y dy. Tacking on the dy since we took the derivative with respect to y. And what about this x? The derivative of x is going to be 1, but tack on a dx because we took a derivative with respect to x. And now, since we've taken the derivative, we want to get all the dy terms on one side, all the dx terms on the other. That actually is already the case. Now, we want to get the dy by itself, so let's divide away the minus sine y. Dividing away the minus sine y, we'll have 1 over minus sine y, but we're still multiplied by the dx. We wish we weren't multiplied by the dx. We wish we had dy over dx. That's cool. Just divide away by the dx, and we'll get dy over dx equals 1 over minus sine y. Now, the issue with this expression and why we don't just circle this as our derivative is because our original function was in terms of x, but this statement is in terms of y. So we want to take a step back and get an expression of dy equals dx, where what is here in this parenthesis only depends on x. And now in order to do that, we're going to need some way to relate x and y, and we actually have a relation with x and y, relating our angle to our ratio. Now the ratio of x, let's see that more as a ratio, because you know any cosine is just an adjacent over hypotenuse. So let's write this x as x over 1 for our adjacent over our hypotenuse. Hell, let me just write this in, adjacent over hypotenuse. And we can draw a triangle associated with that. So we've got an angle of y, we've got an adjacent of x, we've got a hypotenuse of 1. Now we want to know the sine of y. Knowing the sine of y, putting a negative sign in front of it in the denominator over 1 gives us the expression for the derivative. So let's try to find the sine. To find the sine, we'd have to know opposite over hypotenuse. So we need to know this other side. But that missing side can be found because in any right triangle, you can always use Pythagoras. A squared plus b squared equals c squared. And well, a squared would be the smallest side. I suppose that would be the opposite here as I've drawn it. B squared would be the next largest side, that would be x squared, and the largest side, c, would be 1 squared. But we know this side adjacent, we know the side hypotenuse, we want to know the opposite, so we want to solve for opposite. Let's subtract x squared from both sides, opposite equals 1 minus x squared, and then take the square root of both sides. When you would, you'd get opposite equal to 1 minus x squared. And now, the sine of y that we were after is 1 over x squared divided by 1. Note sine of y, opposite over hypotenuse, square root 1 minus x squared over 1, but anything over 1 is just that anything. And now we know our sine y. Now we can plug that in, and we'll get 1 over negative square root 1 minus x squared. And this is an expression for the derivative of the inverse cosine function. Derivative, inverse cosine is minus 1 over square root 1 minus x squared. 4 more to go.